So today we're going to talk about hypothesis testing for means. So this is the first we started about hypothesis testing with means before we've done hypothesis testing for proportions. So we're just kind of switching it over. You'll see it can be pretty similar. There's a couple variations within it, but overall what we're doing here is pretty similar to what we were doing last chapter. So here's our first example. You can read through it here. One of our key points here though is we can read right here. It says, suppose we know that the population standard deviation equals 1. So that's an important thing to know because it tells us what type of test we can do. So here we can see what we're doing is we're testing colas, and we are, we have people that are taste testers and they score it from 1 to 10. And then they store it for a little while, and then they taste it again, and then they look at the difference. So a positive difference here means indicates a loss of sweetness. So here you can see most values are positive, which is an indication of a loss of sweetness. Okay, so if it's a negative, that means that they thought that it actually gained sweetness. Positives lost sweetness. So we have our sample mean down here. It tells us if we calculated the mean, we'd get 1.02. We know our population standard deviation. So we start filling out some of the information we know. We know that the sample mean is 1.02. Population standard deviation is 1. For creating our hypotheses here, then, we need our null hypothesis and our alternate hypothesis. And these aren't any different than what we did before. And now, though, we're looking at the population means. Okay? So, we want to know, if we're reading this here once again, it says, it says, is this data good evidence to say that cola lost sweetness while in storage? So we want to know, is our population mean greater than 0? Because if it's greater than 0, that means it would be a positive value. And remember, positive values indicate a loss of sweetness. So that's why our alternate hypothesis is that. Your null hypothesis then would be less than or equal to. Level of significance is here, tested at 5% or a 0.05 level of significance. And this is our z-score for our actual value. So how do we get that? We can go in. Let me just pull up the calculator here. Alright, so we go to stat, we go over the tests, and you can see the first two is z-test and t-test. Well, z-test is what we want to do here, so we go into z-test. We have the stats in this problem, so we're going to use the stats. So our mean sub 0 is what our hypothesis says here, so it says 0, so I'm just going to keep it as that. Our standard deviation is 1. Okay, oh, we wanted stats, sorry about that. Now, we could take this list and enter this list into one of our lists under stat edit and run it that way, and then you could see we could put the list right there. But since we have the stats, we might as well just save ourselves some time and go right to it. Okay, so our sample mean is 1.02, and our sample size we know is 10. And then this last choice, we choose what the alternate hypothesis is saying. So it's saying greater than p sub, or our mean sub 0. So we calculate it. Here you can see we get z as 3.22. Probably should round it up to 3.23. But either way, it doesn't make too much of a difference. Okay. So if it's a 5% level of significance, this would be a right-tailed test because it says greater than in our alternate hypothesis. Remember, greater than is right-tailed, less than is left-tailed, and not equal to is two-tailed. So if we go back to that chart that we got in chapter 5, or we can use inverse norm, it would be able to give us our critical value here for a 5% level of significance. Right-tailed test would be a positive 1.64. So z would be past that, so z would be in a critical region, so that would mean that we would reject the null hypothesis. Our other method is the p-value method. Remember, we compare our level of significance, so 0.05 to our p-value, which was given in our calculator. So if we look at our calculator, P is 6.29 times 10 to the negative fourth. So I just rounded off here to 0.0006. So that's way less than our level of significance. So once again, if your p-value is less than your level of significance, you reject the null hypothesis. Remember, you do not have to do both of these methods. You can choose one or the other. So our conclusion here would be that we do have significant evidence to show that the cola has lost sweetness while in storage. Okay. So in this case, and I brought this up earlier, it was important that we know the population standard deviation, because that would tell us to do a z-test. But if we don't know it, we have to run what's called a t-test, which was the other option on this. There's not too much different to it. What is different then, though, is how we calculate both our test statistic and how we find our critical value. Okay, so you can read through this. This is just giving you some basic understanding of what you need to do here. It really isn't much different than your other methods, and we'll run through this example here. So Jack and Jill opened a water bottling factory. The distribution of the number of ounces of water in the bottles is approximately normal. The mean is supposed to be 16 ounces, but the water filling machine slips away from the amount occasionally and has to be readjusted. Jack and Jill take a random sample of 10 bottles from today's production and weigh the water in each. The weight is, or the weights are, and here's our listing of weights. Should Jack and Jill readjust the machine? We want to test at a 5% level of significance. So note here, we don't know the population standard deviation, so we will be using our sample standard deviation and a t-distribution instead. Okay. So first thing I do here, as always, is we can go in here and we can run or put in our null hypothesis, our alternate, based off the question. It says, should they readjust the machine? Well, they just want to know, is it different than 16 ounces or not? So that would mean that our alternate is that it's not equal to 16 ounces, which would make our null that it is equal to 16 ounces. Okay, so remember, that would make it a two-tailed test here. Alright, so now we should go in and enter this data in, because we don't have the descriptive statistics for it. We just have our raw data. So we should go into edit, or first you hit stat and then you hit edit, and we can enter it into a list. You can see I already pre-entered it here. So once we have that, we're going to hit stat again. We're going to run over the test, and we want to do a t-test here once again because we don't know the population standard deviation. So we go into t-test. We want to choose data because we don't know the descriptive statistics. We do have the data though. So our mean sub 0 is 16. Alright, because that's what we're comparing it to here, right? Our list, we have our data that we just entered in. I put mine in L1. Just make sure you always check that. Frequency we can keep as 1, and then we enter in what our alternate hypothesis here says. So ours says not equal to 16, or not equal to the mean sub 0. Okay. So we go to calculate, and here you can see, here's my t statistic, negative 1.02, so here's negative 1.02. That's what I calculated. Okay, I'll show you in a minute here how we can find that critical value. Remember, here's our p-value, which is 0.333, so I put 0.33 here. If you do the p-value method, you're going to compare your level of significance, which is 0.05, to your p-value. So our p-value here is greater than our level of significance. Remember, we said that a little earlier. We said that that would fail to reject the null hypothesis. Okay, so how do we find this critical value? Well, we just kind of went over that on Friday. We want to go to second. We want to go to distribution. And just real quick here, though, before I move on, our sample mean here is given to us right here. It's 15.97. Sample standard deviation is 0.08. So you can just enter those two in there. Okay. So once again, to find our critical value, we go to second distribution. And you're going to want to go to inverse t. I don't have that on this calculator, but it's going to be option 4 for you. So you go to inverse t. It's going to ask for your area. Okay. So your area is based on your level of significance and what type of test it is. So this is a two-tailed test. Okay. we have a 5% level of significance, so that 5% is going to be split between each tail. 2.5% on each tail. So you put in 0.025. And then the second option is your degrees of freedom. So your degrees of freedom are going to be your sample size minus 1. So our sample size here, we had 10 bottles here, so you take 10 minus 1, it would be 9. If you hit paste and then you hit enter, you should get a critical value of negative 2.26, but remember this is a two-tailed test, so it would need to be the positive and the negative version of 2.26, so it's positive and negative 2.26. So if our t-statistic falls in between those two, we're going to fail to reject, which ours does here. If it would fall outside of it, that's when we would reject it. So we fail to reject the null hypothesis. What does that mean here? It would mean that we do not have significant evidence to show that the machine needs readjustment. Okay. The last question here says describe what a type 2 error would look like in this problem. So type 2 error, remember type 2 errors are when we failed to reject the null hypothesis when we should have rejected it. So in this case, this means that we said there is no need to readjust the machine, when in actuality it needs to be readjusted. Okay, so you can plan on that. We will go over, there is really only one extra problem here that you need to do, so make sure you complete that. We'll go over that when I'm back, and we will move on a little bit, and then we will quiz the second day that I'm back, so that will most likely be Wednesday. Okay guys.